So I'm going to give you a preview, and then we're just going to dive right in. That's what we're going to do. All right, so Unit 3 is climate, environment, and resources. And so really what we've looked at is what is geography. Then we've talked about planet Earth, and now we're going to look at not only the landforms, but the climate and the environment creates the resources that are available to us. All right, so we have to look at very specific things. So we're going to look at the unit objectives. And our essential question that we're going to try, you should be able to answer at the end of this unit is what factors shape Earth's different environments? So like what creates the environments that we're in, okay? And that means we're going to be looking at weather and climate, and there's a difference. You should know that by now. We're going to look at world climate, so where they're located. So in the latitudes, that makes a huge difference. We're going to look at the natural environments that those two things create, and then natural resources. So one of the cool things that we're going to do is create a soil profile. That's a project that we're going to be working on. All right, so hopefully that'll pique your interest a little bit. So that's like a 3-dimensional profile of soil. And you would think soil's boring, but it's not. It's really cool. Okay.
I love the enthusiasm in that.
You like the enthusiasm? Good, because it's really interesting. Okay. Other things we're gonna focus on. You know how we focus on Ted Ballard? So we're gonna focus on.
I was Robert.
You're right. It was a TED Talk.
Yes.
Robert Ballard, who found the Titanic. We're gonna focus on an environmentalist, also who won the Nobel Peace Prize, Wangari Maathai from Kenya. We're gonna do some coloring. Okay.
I
That'll be
love
fun.
What are we gonna color?
Oh my, I'm scared. All right.
I have a question. Are we gonna have like a lecture or anything tomorrow? Because I will most likely not be.
I'm gonna try to remember to record it,
Okay.
but probably.
Okay.
All right.
If I might be or I might not be, I'm being teased.
I just also want to point out, in the past, I had to take pictures of the pages of the book, but I found an actual PDF of the entire first 4 units. So if you click on the link, it'll actually bring up the first 4 units of our book that we're using. And it takes a little bit because it has 150 pages. But in the explanations of like what sections, I put the page numbers that you can find the information. And I'm going to tell you anyway. But that's for virtual students as well. But if you're working from home, there it is. Okay. And you can actually input, I think we're at page 94. Yeah, what? How do I remember these things? I don't know. So there's 4 sections or 4 lessons, and today we're going to start on weather and climate, okay? But before we do that, I'm going to show you a quick video, an intro video, just to refresh your memory on the differences of weather and climate.
Isn't climate like an overtime thing and weather is like?
Yes.
There you go. Brandon, will you put the lights for us, please?
If you're like me, you know what your perfect day looks like, weather-wise. Sunny, rainy, snowy, whatever. Personally, I love it when it's cool and cloudy, like just cold enough to wear a sweater. You probably know that weather has something to do with how hot or cold it is outside. But really, there's a lot more to it than just temperature. So grab your sunglasses, your rain boots, and your most colorful scarf, because today we're talking weather. Let's start with a big and pretty basic question. What exactly is weather? Well, weather is the condition of the air, or the atmosphere, on our planet. But the thing is, even though there's only one atmosphere on Earth, the weather isn't the same all over the world. There are many different factors that can change the atmosphere in a certain area, and together they determine what the weather is like from one minute and from one place to the next. These factors include temperature, humidity, wind speed and direction, and lots of other things. But when you're talking about the overall weather patterns from a certain region of the world, you're talking about the area's climate. Weather is the minute-by-minute changes in the atmosphere. Climate is what the weather is like over a long period of time in a specific area. Now, the weather is constantly changing all the time, every day. Think of the weather as being like that one friend of yours who can never make up their mind about what movie they want to see or what restaurant they want to go to. Just because it's beautiful and sunny outside when you wake up, that doesn't mean you won't need an umbrella before the day's over. And raining is just one of the things that weather can do. Rain, of course, is just a form of precipitation, or water that falls from the sky. It happens when droplets of water in the clouds, or sometimes ice crystals, get heavy enough and fall to the ground. If they're crystals, the warm air near the ground will melt them as they fall, forming liquid raindrops. But do you want to build a snowman? Another common form of precipitation is snow. Snow is just ice crystals that don't melt into liquid water as they fall. Another snow-like form of precipitation is sleet. It's what happens when ice crystals fall toward the ground, partly melt, and then refreeze again. But other kinds of weather can be way more severe, and the most common kind of extreme weather is a form I'm sure you're familiar with: thunderstorms. A thunderstorm can happen when strong winds make drops of water and pieces of ice collide and break apart inside a storm. This causes electrical energy to build up, which creates a little something called lightning. But all of this rain and snow and sleet I've been talking about, that's all just weather. And while weather can change in a few hours, a region's climate takes hundreds, thousands, even millions of years to change. So how can we better understand the difference between weather and climate? How about we send Cartoon Sabrina on a little imaginary trip for a month? Okay, here she is at her destination, Yuma, Arizona. Let's pretend it's the 5th of the month. On this particular day where Cartoon Sabrina is, it's warm but very cloudy and the light rain has been falling on her, sorry me, all day. Since clouds and rain are what the atmosphere has to offer on this particular spot at this moment, and they can go away at any minute, those conditions are, the weather. Now let's fast forward to the 10th of the month. Hello, sun. Looks like Tiny Me won't be needing an umbrella today. How about the 15th? More sun. The 20th? Still sunny. The 25th? You guessed it. Sunny with a chance of, well, sunny. And finally, on the 30th, the sun's still shining. Little Sabrina, I hope you packed your sunscreen. So what does this quick time lapse of a month in Yuma tell us? It tells us that Yuma, Arizona is a pretty sunny place. In fact, on most days, it's one of the sunniest cities on the whole planet. So the city's weather patterns existed before Mini-Me arrived and will continue after she leaves. In that case, you could say that Yuma has a sunny climate, even if its weather on a certain given day happens to be rainy. Now you know that weather is much more than just temperature. It's the condition of our planet's atmosphere, and it's constantly changing. You also know that weather and climate are not the same thing. But I saved the extreme stuff for last. The severe weather stuff, that is. You'll have to tune in next time to learn more about tornadoes, hurricanes, and blizzards.
So that's a quick summary of the differences between weather and climate. Yes, they're related, but time is the difference. Okay? All right. So what I'd like to do next, I think I have to go back. Yars. Okay. Is the weather and climate lesson. So today we're going to read, we'll start on page 50. So if you'll open up your page 50, we're going to do some reading, but we're also going to take some notes. All right, so you're going to need some paper and pencil. So I'm going to do very similarly to what we did last time, and I'm going to project what you tell me. This time you're going to tell me what I should write. Okay? Yes. Will you turn the lights on, Brandon, for us? Appreciate it.
That loud.
Yeah.
Whoa.
Okay. So I'm gonna go to page 50, I think, is. What do you think our title should be?
Weather and climate.
There you go. Weather and climate. Ding, 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 ding. Piece of paper. Need something to write with.
I need to show the weapons.
Go for it. Now, what do you think will be some of the subheadings for weather and climate?
Understanding weather and climate.
Okay.
I think difference between weather and climate. Something like that.
Okay, so we need a definition maybe? Alright, so we're gonna say, you told me weather and climate is going to be the title. Sweet. Okay. So we need the definition. Do we need to write the definition? How about you write your own definition of weather and climate? And if you want to do what it says in the, or like highlighted portion of the book, you go for it. So weather, climate, spelling correctly would be good, but you know, abbreviate if necessary. Right? Weather. I went technical and said atmospheric conditions. You can go that route or you can go however you want. I don't know. What do you think? Do we need to read the understanding weather and climate portion?
No.
Or can we move on to the next thing? I think so. Now, if we look at what the big idea is, it shows it right. Of course, go right there. Yeah, my book. The sun, location, wind, water, and mountains affect weather and climate. So that's really what we're going to be looking at is what is affecting the differences or creating the differences in weather and climate. So once we have our definitions, I think we can move on to our first factor. What is it?
Sun and location.
All right. So I'm going to put sun and location. I'm going to underline it. Do whatever. So can someone actually read sun and location?
Yeah.
Ava, please.
Energy from the sun heats the planet. Different locations receive different amounts of sunlight, though. Thus, some locations are warmer than others. The differences are due to Earth's tilt, movement, and shape. You have learned that Earth is tilted on its axis. That the part of Earth tilted towards the sun receives more solar energy than the part tilted away from the sun. As the Earth revolves around the sun, the part of Earth that is tilted towards the sun changes during the year. This process creates the seasons. In general, temperatures in summer are warmer than in winter.
Okay, so let's time out. So sun and location. What could we maybe possibly write down?
Changes the seasons.
Okay, we could.
Different locations receive different amounts of sun.
Yeah, I think that's the biggest part. And the reason is because of what?
The
The
tilt.
tilt,
rotation and
which
rotation.
creates the seasons. Okay, so we're gonna. How would we write that? We want to write a long paragraph or?
No. Okay.
I would put
One
bullet points
sentence.
and then say
Wait, hold on, let me look at it.
What about different locations get what?
Different amounts.
Different amounts of what?
Sunlight.
There you go. Amounts of sunlight. I might even put why. And then Dixon said because of the
Rotation axis.
Tilt.
tilt. The rotation gives us what?
Or sunlight. Solar radiation.
Yes, but if we rotate on the axis, what does it give us?
Days.
Days. Okay. All right. But the different amounts of sunlight is because of the tilt. You can read that. Tilt. Okay. Awesome. So, okay. I think we got that. All right. Continue for us, Ava.
Earth's shape also affects the amount of sunlight different locations receive. Because Earth is a sphere, its surface is rounded. Therefore, solar rays are more direct and concentrated near the equator. Nearer the poles, the sun's rays are less direct and more spread out. As a result, areas near the equator called lower latitudes are mainly hot year-round. Areas near the poles called the higher latitudes are cold year-round. Areas about halfway between the equator and the poles have more seasonal change. In general, the further from the equator or the higher the latitude, the colder the climate.
Okay. So I put Earth's shape has a factor, is one of those factors in weather. Okay. Because it's a, what is it? It says a sphere. You could say spheroid. Though if you study it more, they're going to call it an oblate spheroid because it's not a perfect sphere.
Because that pole is sort of
They're kind of squished. Yeah.
It's like an onion.
Earth's what?
Earth's shape. So sunlight is concentrated at the equator, right? Because that's the farthest or the closest to the sun. Those are called the what kind of latitudes?
Basically.
Cap or the.
Well, are they low, medium, or high?
Low.
Medium.
High.
What degree is the equator?
0.
So is that a low or high number?
It's a medium. Low.
Low.
It's a medium.
It's a neutral number. It's the only neutral number.
Yeah.
Low latitudes. So we're talking like tropical areas go from 0 to 30 degrees, both north and south. Okay. So low latitudes. So obviously there's way less sunlight at the poles. So what latitudes would those be at?
180. Or would it be
180 and negative
90?
So it only goes to 90. Okay. 90, 0 to 90 at the north, 0 to 90 in the south. So if these are called low latitudes at the equator, then the poles would be called what kind of latitudes?
High.
High latitudes. So this is like where your extreme, not seasons, extreme climates are going to be located. Well, guess where we live?
in the medium latitude.
Yeah, we've also called them middle latitude. So about, what do we say? We're at 35. Yeah. Yeah. And we'll talk about those later. All right. So this is where the most is. And so most sunlight. And however you want to write it is up to you. If you want to draw pictures.
Oh.
Sometimes I draw sun, not the sun. All right, awesome. Lunar climate. All right, so sun and location is one of the factors that affect weather and climate. What's the next one?
Whoa. Oh wait, no.
Wind and water.
Wind and water.
Wind and water. Dylan, you want to tackle that one?
Yeah. Heat from the sun moves across Earth's surface. The reason is that air and water warmed by the sun are constantly on the move. You might have seen a gust of wind or a stream of water carrying dust with it. In a similar way, wind and water carry heat from place to place. As a result, they make different areas of Earth warmer or cooler.
All right, so we're going to talk about, obviously the sun is going to warm the air and the water. Have you ever been in a lake and you're like swimming along and then all of a sudden you're like in a cold section?
Yes.
You're like,
Yeah.
holy mackerel. I don't like that. It's not, ugh, don't like it at all. I just don't like being in lakes in general because I can't see the bottom. But anyway, that's a totally different story. So the air is heating and cooling. Now, what happens when metal heats?
It
melts.
expands.
It expands up to a point. It could melt, yeah. And when it cools, then what does it do? It
condenses.
contracts
It
or
solidifies.
it solidifies.
Like
Okay.
if you blow up a balloon, like
Yes, but what my
Well, no,
metaphor
a
is
filled balloon. Whenever it gets hot, it expands, and whenever it gets cold, it shrinks.
does. So do tires,
Yes.
by the way. Okay. So what we're saying is the sun is heating up the air. And when air molecules are heated up, so they get really excited. They're moving constantly, up almost to they're already in a gaseous state. Okay. So they get really excited. And what happens to hot air? Where does it go? It does. And when it gets further and further into the atmosphere,
It condenses.
it cools down. Okay. So those excited molecules, they got to get together. Okay. Because they're cold. So they're going to condense and maybe even form water droplets. Or if it's cold enough, what does it do?
Snow.
Or
Precipitate.
precipitates or becomes some solid matter.
ice.
Okay,
Hail.
into ice or
Hail.
hail. Right.
Wow.
All right. And then falls. But we're still talking about the air. There's water vapor in the air, but still those molecules are either excited because they're really hot wherever they are in the atmosphere, and then they're constantly being heated up and then cooling down. And they're not staying in the same place. Okay. So, and you can see that in your picture on page 51 here. So this is where we start talking global winds. So if you've ever flown in a long plane ride, which direction do you want to go? Do you want to be with the wind or against the wind?
With
Why?
Because it makes you go fast.
turbulence.
That
Like the wind pushes against you, and that thing.
it could, yeah. So
What can happen?
So wind can even be different levels. So you can have a slow jet stream here. You can go further and you get in a higher jet stream, or it can be going in a totally different direction. All right, and that is part of the heating and cooling process. It's really interesting, and I don't understand all of it, but enough to be maybe dangerous. I don't know. Okay, so let's talk about these global wind systems and how they're actually created. Dylan, you want to keep going?
Yeah.
Okay.
Wind, or the sideways movement of air, blows in great streams around the planet. Prevailing winds,
Or
Yeah.
winds.
You're right.
prevailing winds are winds that blow in the same direction of the large areas of Earth. The diagram above shows the patterns of Earth's prevailing winds. To understand Earth's wind pattern, you need to think about the weight of air. Although you cannot feel it, air has weight. This weight changes with the temperature. Cold air is heavier than warm air. For this reason, when air cools, it gets heavier and sinks. When air warms, it gets lighter and rises. As warm air rises, cooler air moves in to take its place, creating wind.
Wind. Yep. All right. So I don't know why it's not highlighted, but wind, I would like to know exactly what wind is. So that's what I'm writing down. Around great streams around the planet. So I wrote down the definition of
I need for Bruce Van Loren to come to the office, please.
and then prevailing winds. Same direction constantly, right? Over large areas. Same direction. I should have said blowing in the same direction. Something like that. So if you look at that diagram, what are the prevailing winds called? They have special names.
Air streams.
Look,
Yeah, it says wind.
look where the arrows are. The purple arrows.
Trade wind?
Trade winds. What else are they called?
Westerly.
Yes, and
Doldrums.
the doldrums, the westerlies, the easterlies, and trade wind, also known as trade
I have a
winds.
question. What creates wind?
Not only the heating and the cooling of the air because of the sun, but also the rotation of the earth. Right?
Yeah.
So think about that. The rotation of the earth it's moving. So it's also pushing the air. Same thing with the currents in the ocean as well. So the rotate, I know, it's hard to comprehend.
Technically, the ocean is just like another Earth, just like underwater. And I wonder if air is the fish's water.
There's
No.
oxygen in
There's
the
oxygen
water.
in the
Yeah.
water and the gills process that. Yeah.
Yeah, but like if it it's like no, like if they come out of so you know how we go underwater we can't breathe. You know how they come out of water they
And they
can't breathe. Evolution.
I don't know about that.
I mean, it takes a while, but
All right.
Uh-huh.
All right. So we already introduced a little bit of what Dylan read, and that the hot air rises and the cool air sinks, but it's not just in. So like, oh, how do I want to throw my pen up in the air? So that'd be like hot air rising, cool air falling down. But if the room moves, is the air in the same place?
yeah.
Yeah. No.
No,
No,
it's not.
Gravity.
It can
Right.
go through walls.
No, it can't.
I don't think it sticks to stuff.
Okay. So that's how wind in particular is made. And then there's other, you can have, I should bring my husband in here because he loves weather and studies it. And he can tell you about like when thunderstorms happen and there's like a huge gust of wind. There's all sorts of things happening when that's when going on to create stronger currents of air.
FaceTime.
No, he's teaching.
So he's a teacher too.
All right, so Dylan, flip the page back to 52 and talking about wind.
Right there on a global scale.
Yeah.
On a global scale, this rising, sinking, and flowing of air creates Earth's prevailing wind patterns. At the equator, hot air rises and flows toward the poles. At the poles, cold air sinks and flows toward the equator. Meanwhile, Earth is rotating. Earth's rotation causes prevailing winds to curve east or west rather than flowing directly north or south. Depending on their source, prevailing winds make a region warmer or colder. In addition, the source of the winds can make a region drier or wetter. Winds that form from warm air or pass over lots of water often carry moisture. In contrast, winds that form from cold air or pass over lots of land often are dry.
Okay, so I added to the notes heating, and we're talking about air, right? Heating leads to rising, cooling leads to sinking, but rotation, I added rotation there. Okay, so wind patterns go in which direction? East to west, or east and west.
East and west. Wait, but like.
Instead of going up and down, because if the earth was still, that's what would happen. But because the earth is rotating, it's, and like up and down. If the room was moving in a certain direction, then the air is going to be moving as well.
Yes, I got so. Like in a car, if you throw something up, it goes with you. If you used a speedometer on that thing, would it register as moving or as just?
Oh my gosh, I don't know. I don't know.
I said that if you throw like a pin up in a car and use a speedometer on it,
Oh, yeah.
would there be a speed on the pin, or would it
It
have no speed?
It doesn't just go.
No, it would have speed because it's inside the car, which is moving.
And then it
Uh,
flies.
but it would
jump
still
off in
slow-
the car.
Right, that's true. But if it didn't have any speed, it would fly back and hit your face, right?
Isn't that
Yes.
like Newton?
I'm sure it's some Newton's law of something. I don't know. Okay.
Is that
The giant
Newton
hunk of stone does not have.
Does that make sense? Because it does keep going and doesn't hit you in your face. That means it has speed and it is still traveling. Okay. But not as fast because gravity is pulling it back down. It'll come a little bit towards you.
How fast does the Earth rotate?
Very.
I don't know. Write that question down
And
and then someone can look it up in a minute. That's a good question.
I don't know.
I think it's like
Might be slower than-
I think
Huh?
All right. So wind patterns go east to west. So how do you think ocean currents work?
air.
it's like the heating of cooling because isn't there like different temperatures in the ocean? So like yeah, it would be like
Would it be similar to the wind currents?
yeah.
Possibly. Let's see.
Yeah, they
Okay.
the ocean boils some places.
Wait, no, how? There's lava.
There's magma.
All right. So whoops. So the next section, still under wind and water, is ocean currents. Who wants to tackle that one?
Carol,
Sydney? Oh, Dixon? Okay. I'll get you, Sydney.
like wind, ocean currents, large streams of surface water, move heat around Earth. Winds drive these currents. The map above shows how Earth's ocean currents carry warm or cold water to different areas. The water's temperature affects air temperatures. Warm currents raise temperatures, and cold currents lower.
Okay. So I just wrote down the ocean currents definition. That went fast. Seems like, anyway. Okay. Nice. So just finish that, and we'll pick it up tomorrow and talk about
What's after large stream?
surface seawater. So if you go further down into the ocean, what temperature do you think it's going to get? Cold. Yes. Unless you are near like a vent, like we saw in the TED Talk. That was cool.
What's the deepest part of the world?
Mariana Trench, I think, is the
Yeah.
deepest part
It's
of
like 10
the ocean.
miles deep.
Yeah, it's crazy.
What happens if you
What's
went down there
that
with
O
like
thing?
only
You would die.
scuba diving gear?
You would die.
What if you're a submarine
Do you want me to
If you went into the Mariana
that'd be
Trench,
You can spray,
Okay.
and then if someone will.
What if you're in a submarine person?
Well, it depends on